Imagine this. Beneath the crust of an ancient asteroid, there's a secret so astonishing it could change how we understand the universe. What if I told you that hidden within some of these celestial bodies might be tiny black holes, relics from the birth of the universe itself? These black holes are so mysterious, so incredibly fascinating, that understanding them could completely reshape our view of space and time. Welcome back, dear traveler, to a space trip, but this time to the present day. But before we jump in any further, I've got to give a massive shout out to our awesome Senator member, SNHU student. Your support helps keep these journeys alive, and 100% of all contributions go back into making more videos for History Chibi. If you want to be like SNHU student and get exclusive perks, you can become a member of our community today. Whether you join as a citizen, senator, or go all out as a council member, there's a tier for everyone. So hit that join button and let's explore the universe together. Oh, and one more exciting update. History Chibi merch is finally here. From cozy hoodies to fun mugs, there's something for every history lover. Check out some of the products below this video or head to historychibi.shop to grab your 2024 election season gear and support the channel in style. Alright, now let's get back to our cosmic journey. Today we're exploring one of the most mind-bending possibilities ever explored: primordial black holes, their strange behaviors, and their potential influence here on Earth and beyond. From their formation in the very first seconds after the Big Bang to their potential role as dark matter, these elusive entities hold the keys to some of the universe's most profound mysteries. We'll explore how they could be hiding in asteroids, what they could mean for future technology, and why finding even one would be a monumental breakthrough for humanity. And trust me, you're going to want to stick around until the very end because the most astonishing possibility is yet to come. Primordial black holes, or PBH for short, are a relic of the early universe. They may have formed just moments after the Big Bang, during a time when matter was distributed in such a way that tiny regions could collapse under their own gravity, forming black holes. Unlike the giant black holes you may be familiar with, the ones that lurk at the center of galaxies, these are incredibly small, weighing somewhere between the mass of a mountain and the mass of a large asteroid. But even though they are tiny, their gravitational pull is no joke. And here's where it gets fascinating. Picture a massive asteroid drifting in the cosmos. Now imagine a primordial black hole passing by, or even getting caught inside. If this tiny black hole becomes trapped within an asteroid, it might slowly start eating away at the asteroid's core, hollowing it out bit by bit. The dense core would vanish, leaving behind an empty shell, a cosmic husk, with the black hole sitting quietly at its center, like a ghost in a haunted house. What a haunting image, right? But this is more than just a spooky idea. The researchers propose that we might actually be able to find hollow asteroids or planets with such black holes at their core. Imagine finding a hollow cavernous asteroid, a massive floating labyrinth formed because a tiny black hole devoured its insides. The shell, if made of strong enough material like granite or iron, could potentially withstand the gravitational forces and stay intact. Think of this as a natural version of the Death Star from Star Wars, but without the evil empire behind it. The fascinating part is that scientists have actually done the calculations to see if this is possible. They found that materials like granite or iron are indeed strong enough to support a hollow structure around a tiny black hole, provided the black hole isn't too massive. The hollow asteroid could be as large as 1/10 the size of Earth. They even considered the strongest man-made material multi-wall carbon nanotubes, which would allow for even more impressive structures. Imagine a giant hollow moon, a labyrinthine husk floating in space, supported by nothing more than its outer shell. The researchers also explored the concept of the stability of such structures. One crucial question is whether the outer shell of these hollow bodies can support itself, or if it would crush under its own tension. To determine this, they used general relativity to find the ratio between the surface tension and surface density of the shell, and compared it to the compressive strengths of known materials. The results showed that natural materials like granite and iron could indeed hold up under the gravitational forces involved, meaning these cosmic shells are not just a fantasy, they could be real. And it doesn't stop there. If we extend our imagination even further, one day advanced civilizations, maybe even humanity in the distant future, could harness the power of black holes to extract energy. Picture giant Dyson sphere-like shells, not around stars but around black holes themselves, using Hawking radiation and the immense gravitational energy to power whole planets. The researchers suggest that these shells could be built from the strongest materials we know, even something as advanced as carbon nanotubes, but they would have to be at a safe distance to withstand the incredible forces involved. This is some next-level sci-fi, but grounded in real physics. To put this into perspective, they calculated that if you wanted to build a shell around a black hole as massive as our Sun, it would have to be placed at least 10,000 times the radius of the Sun to be stable. That's a distance of nearly 7 million kilometers. Even multi-wall carbon nanotubes, one of the strongest materials we currently know how to make, couldn't handle the gravitational force any closer than that. But if built correctly, such a structure could allow us to harness the incredible energy of black holes. Imagine how transformative this could be. Think about a future where energy is harvested directly from black holes, a virtually limitless source of power capable of fueling civilizations for millennia. The concept of using black holes as energy sources could be humanity's key to becoming a truly interstellar civilization. Instead of just harnessing energy from stars, we would be using the universe's most enigmatic objects to sustain our future. It's as if science fiction is slowly transforming into reality, and you and I are witnessing the first steps towards a world that was once only dreamt of in movies and books. If that hasn't caught your interest yet, here's the kicker. These primordial black holes might be a lot closer to us than we think. Imagine looking at very old rocks, maybe some ancient granite, or even an old metal structure right here on Earth, and finding a perfect narrow tunnel drilled straight through it. The researchers believe that these tunnels could be evidence of a primordial black hole that passed through. If a tiny black hole passed through Earth, it would be incredibly fast, leaving behind a narrow path, a ghostly scar in its wake. The good news? We could potentially find these tunnels using nothing more than an optical microscope if we know where to look. Here's how it would work. If a primordial black hole, weighing somewhere around 10 to the 22nd grams, passed through a solid object like a slab of metal or a piece of rock, it would leave behind a tunnel about 0.1 microns wide. That's just large enough to be visible with a regular microscope. These tunnels wouldn't just be random dents or cracks, they would be straight cylindrical paths, like something drilled by a perfect cosmic laser. And the researchers suggest that Given enough time, we could even look for these tiny tunnels in old buildings, ancient slabs of stone, or even glass structures that have been standing for hundreds of years. Imagine finding evidence of a black hole's journey right here on Earth. How incredible would that be? The paper also points out that these primordial black holes could serve as dark matter candidates. Dark matter is one of the biggest mysteries in astrophysics, accounting for about 85% of the matter in the universe, but we still don't know what it actually is. PBH might be part of the answer. If they exist in sufficient numbers, they could help explain why galaxies hold together, why stars move the way they do, and why the universe behaves as it does on a large scale. Finding evidence of a primordial black hole in an ancient rock here on Earth wouldn't just be proof of these exotic objects. It could also be a major piece of the dark matter puzzle. Think about that for a moment. The remains of black holes that pass through matter hidden in the ancient structures of our world. It's like the universe has left clues scattered all around us, clues that could lead us to answers about how everything began. And even more, these clues could connect us to the vast unknowns of dark matter, a mystery that has perplexed scientists for decades. Imagine if the key to understanding dark matter lies not in advanced space missions or deep space telescopes, but right here in the ancient rocks beneath our feet. And here's the ultimate mystery. Although finding these microtunnels is extremely unlikely, the payoff would be monumental. If we could find one of these tunnels, we'd have undeniable evidence of primordial black holes, physical remnants from the very dawn of our universe, proof of a relic that can tell us more about how everything began, and perhaps about the mysteries of dark matter. Could we be living right above such secrets, hidden within the very rocks beneath our feet? The sheer possibility of it is enough to ignite the imagination. Just think, one discovery could unlock the secrets of the cosmos and propel our understanding of the universe light years ahead. The researchers also considered the timescale for how long it would take a primordial black hole to eat through the core of an asteroid or even a planet. The time required depends on the density of the material and the mass of the black hole, but they estimate that a small black hole could hollow out a kilometer-sized asteroid within just a few years or months, depending on the conditions. This means that some of the hollow asteroids we find today might have once been filled with liquid metal or other dense materials, now long gone, consumed by an invisible cosmic force. These hollow shells could be remnants of events that took place millions or even billions of years ago. Additionally, the paper discusses how small primordial black holes could pass through planets, including Earth, and leave little to no seismic impact due to their incredibly small cross-section. Imagine a tiny black hole zipping through our planet at incredible speed, leaving behind only a faint, narrow tunnel without causing any significant damage. In fact, they might even trigger tiny, localized earthquakes, too small to be dangerous but potentially detectable. The idea that a primordial black hole could pass through the human body without causing harm, because it is so small and moves so quickly, is both terrifying and awe-inspiring. The damage it would cause would be minuscule, and the human body would simply close up around the tunnel as if nothing had happened. The researchers suggest that we could prepare polished slabs of metal or other solid materials as detectors. By scanning the surface over time, we could potentially detect the sudden appearance of a tunnel, a telltale sign of a primordial black hole passing through. Such detectors wouldn't be expensive to build, and the possible reward, a glimpse into the fundamental nature of our universe would be incredible. Imagine a slab of metal sitting quietly in a lab, suddenly showing a microscopic hole one day, proof that a primordial black hole just visited. And consider what this could mean for the scientific community. It could spark a new age of exploration, a race to locate and study these primordial signatures. With every potential discovery, our understanding of the universe would deepen, and the implications for technology, energy, and even our place in the cosmos would be profound. Perhaps it would lead to a new branch of science, dedicated solely to studying primordial black hole remnants and their effects on celestial bodies and planetary geology. The ramifications are nearly endless. This is the kind of mystery that keeps scientists up at night and might one day redefine what we know about the universe. So, if you're ever exploring an old building or some ancient piece of rock, remember, you could be standing above a billion-year-old secret, a black hole's whisper that no one has yet heard, and if we do hear it, it could change everything. The universe is full of surprises, and there is so much left to discover. We've barely scratched the surface of what's possible, and every day we uncover new mysteries that challenge our understanding. What if we are on the verge of discovering something that shifts our entire perspective? Imagine how thrilling it would be to be a part of that, to witness a discovery that rewrites the textbooks. And who knows, perhaps one of you watching right now might be the one who makes that discovery. So, dear traveler, may you feel inspired to know that you could be the one to help change humanity and science as we know it. For now, have a restful night, and if you enjoyed this journey, don't forget to like this video and subscribe for more fascinating explorations into history. This video was more science-focused, but I think it plays a large role in history as well. But do let me know what other topics you would like to explore together. I have a huge list, and I'm working diligently to get them into a storytelling format for you. Until next time, dream big, dear traveler. Good night.